All right, let's start. Great. Thanks for joining, everyone. Hi, Joe. Nice to see you again. Joe is our host of the webinar, and I'll do a quick introduction. Ankush is also here. He's my co-founder, and Joe has met Ankush. I'll start with a quick agenda, guys. Let me just share my screen first. I hope you all can see the screen. All right, great. So we have about 50 minutes, and that should be good. It's a working day, so 50 minutes should be good for this webinar. I'll introduce Joe. I'll briefly introduce DevSecOps as a topic, and then we'll have a lovely presentation by Joe here on how to implement API security in DevSecOps. And towards the end, I'll talk about your 2024 roadmap. It's a 5-minute, very crisp roadmap for DevSecOps adoption for API security. And lastly, that's 5 to 10 minutes. We'll open for Q&A. You can ask questions right here. We'll have our team answering those questions. Anything you have around API security, DevSecOps, anything you want to ask Joe, Ankush, or me here, feel free to do so. All right. So Joe here, you finally see his face because here we don't have his face, but now you finally know who Joe is. Lovely human being. It actually started from DevCon 2023 last year in August. I remember we met on August 12. Both Ankush and I were presenting on this topic, open source API security. And I think you can briefly probably see Joe here towards the right. He's standing over here in this packed audience hall in the AppSec village at DevCon. He attended our presentation, and then we met and we discussed bunch of topics around shift left security, API security, how to secure APIs in the DevSecOps pipeline, and so on. And what we really realized is that our common passion is API security in DevSecOps. And I'm so glad, Joe, to have you here and talk about this topic. This is really the mission of Acto, and I'm glad that you're able to talk about your experience in this area. Joe, he's VP AppSec at Wells Fargo. He's led AppSec in multiple organizations, and really this talk is going to be very valuable for people who are trying to implement API security in their DevSecOps pipeline. I'll give very brief introduction on what DevSecOps is. Both Ankush and I have given multiple talks on this topic last year with OWASP chapter, LA, San Diego, I think SF, and multiple others. So I can share with you all the recordings that we have post the event. But briefly, what DevSecOps really means is it aspires to shift security left. Now, you see a lot of security controls over here. Traditionally, DevOps was all about design, code, test, deploy in production. But now you see there are I guess 14 security controls over here. It is security by design, at code analysis stage, at testing stage, vulnerability scanning, infrastructure protection, and whatnot. So what really it means is implementing security within the DevOps pipeline is actually DevSecOps. And I want to tell you about the companies who are doing this very successfully and why this is important. There are companies like Netflix, Adobe, Twilio, Capital One, Comcast, Etsy. All of these guys have actually implemented DevSecOps. And these are large companies we're talking about. So it's taken them years, but they've really successfully adopted this. And lastly, I think I'd want to say that this is not really just a technical implementation, but it's really a cultural shift. Traditionally, DevOps meant, optimizing for fast delivery and QA. and teams involved were devs, platform, and infra. But it's not the case anymore. It really optimized for fast delivery, QA, and security now. So really, these 5 stages is what towards the end of the webinar I'll cover also in the roadmap. You want to have security at design, code, testing stage, have the right feedback loops, and monitor. So that's DevSecOps, and now I'll give Joe the stage to give this wonderful presentation. Joe, why don't you start with a quick introduction of who you are?
All right, let's do that. Thank you for having me here today. Let's see, I need to click at least one more button. Can you guys see the screen share? I can see it. Anybody give me some feedback? Can you see it? Akita's on mute, but she's saying something.
Oh, yes, we can. Sorry, I thought.
Okay. Oh, now I see the thumbs up there. Okay. So we're going to talk about DevSecOps. There's a lot of correlations between what Ankita just said and what I'm about to say, and we didn't coordinate anything ahead of time, so that's interesting. I used to be a senior embedded software developer, senior web developer, and eventually caught passion for application security, and that's what I've done as much as I can ever since for the last 14 years or something. And so I do a lot of that. Here's some certificates, and I presented a few things here and there and try to advocate for DevSecOps being a shift left and being secure by design. So those will be some of the things I emphasize here today. And here's what we're going to talk about. What's the basic definition of an API? Just as a review for people. What's a paved road? Why does OWASP think it's a good idea? What does that look like for an API? And a lot of what we're going to cover applies to both API and other types of things that one might develop, other types of code one might develop. And as Ankita said, we're going to emphasize the concept of AppSec throughout the SDLC and standards, processes, tools, and especially shift left. Let's see here. Don't know how to make this go away, so smaller maybe. There we go. All right, so a couple caveats. This is just an intro talk. We could go a lot deeper into these things, particularly if you want to hire me. I work remotely and been in the same place for a while. Wouldn't mind considering other things, but you almost have to get too much deeper than this, you almost have to have a much longer presentation or an ongoing working relationship where you delve into the specifics of the company, because there's a lot more to it than this. But this will get you started in a good way. All right, so what is an API? An API stands for Application Programming Interface, and it's the interface that this service provides here. You could think of it as the top layer. Maybe in the future I should draw it as a little layer across the top of the service that the client interacts with. And so people will use API for all sorts of different components of this system or for the system as a whole. And we just need to understand that and figure out what people are saying. But the way I'm going to use it in this talk, the API is a layer provided by this service. That's the interface that the client uses. So a client sends a request, gets a response, and consumes the data that it gets. So in a simple environment, you might just have a client, which would be an actual machine someplace, because we're not going to talk about cloud today. You can, I have, but not this time. So you've got a machine out here that's a client, and you've got a machine out here that's a service. You might want to put some kind of protection between them, like a reverse proxy or an API gateway that we'll talk about in a minute, but you still have the basic idea of client sends request, gets response. So that's what we're talking about, and obviously you can dive much deeper into that. What we want to talk about next is the AppSec paved road concept that OWASP goes over, and it's basically reusability. It's basically making everything easy when you go to develop a new microservice, a new client, anything new that you've done before. Let's make it easy so you know what all the steps are and you can easily progress through it. So that's what we're going to talk about here today. When we talk about application security, we're going to look at ways to make it easy. Now, all of these standards listed here are all trying to do the same thing of help you build an AppSec program, but you can spend weeks studying BSIM and still not know how to start. OWASP OpenSAM is a little bit more accessible, but it's still just high-level directives. But the idea is to impose something where you can get secure by design. So you get reusability, you get maybe a design pattern that includes tools and processes and things that you use in every stage of the SDLC. That's what we're going to be talking about here. So this is slightly different wording, the one Ankita was using. It's also slightly different wording than I like to normally use. I like requirements, design, develop, test, deploy, and then you'd have monitoring after this. But the idea is this applies to Agile as well as Waterfall, as well as all kinds of other development methodologies. You tend to go through all these stages and then go back to the beginning and write some more code and deploy it. And so for Agile, you would do smaller bits of code, get them through here, find some problems, go back here. But the same general idea applies, is that your code, and this is actually, in this case, it's the code that somebody's developing, gets planned, gets requirements analysis, code gets designed, built, test, etc. So in all of these diagrams here, we're looking at the code that somebody is writing, the microservice code that's going to provide the API. Here's the example I'm going to use. And we're going to ask, how can developers secure it in each phase? And what can we do to get reusability in there, get tools in there that help to make developers' lives easier? And that's the paved road concept we were just talking about. All right. Jump in with any questions at any time, please. It makes everything much easier to understand for everybody. So for the planning or requirements gathering phase, you can go dig into those standards I talked about, and they say, okay, for maturity level 1, you're going to do this, and 2, you're going to do this, and 3, you're going to do that. This OWASP OpenSAM is a good way to summarize what should happen here. But basically, you're going to say, hey, what are we doing, and what are all the security requirements that apply to it? And some of those requirements, we're going to write them all down here, maybe list them on the backlog if we're doing Agile. But they may apply to this phase or to any of these phases. They're all requirements. There are things you have to do for security in each phase here. And so when we list these requirements, some of them are going to apply to the design phase, or what they call here the build phase that I call development, where somebody's writing the code, or any of these phases, really. So you could, at this point, identify a bunch of reusable solutions as well in the planning phase that typically overlaps with the design phase. Questions or comments so far? Okay. In the requirements phase, we start asking questions like, oh, there shouldn't be a 3 there. What kind of product are we building for this project? So in this example, we're going to build the microservice that provides the API, that interface that allows people to just go to a URL and get some stuff. And then what security requirements do we need? Well, we decide, hey, we need to either create or use something we already created, or find a solution out there on the internet somewhere, or get our people to build something, but we need a reusable solution, and it's got to do these things. Now, this is a shortened list that emphasizes the application security things that need to happen, but microservice means tiny and fast. So it's a very small, easily developed thing here that's going to provide our gateway. We're going to use maybe OAuth and IDC for authentication authorization, etc. You can see here, we'll talk about Apogee API Gateway in a minute. We need to have code that defends against both the regular OWASP top 10 and the API top 10, because they both apply to this. And somebody's got to write this client. So the API, the regular OWASP top 10 would apply to the client, and both the regular and API versions would apply here. So this is an example of what we might do, a very shortened example of what we might do in the requirements phase, the planning phase. So now we're going to design things, and now the code that you just gathered requirements for, you're designing it or reusing a design that you already did. But basically in Agile, what you would do is anytime you pull a feature off the backlog that's sufficiently complicated, you need to design that. You need to think about it. You can't just jump in. There's a Dilbert comic strip that says Agile is just skipping all the planning, all the designing, and jumping straight to writing code and complaining. That's not how it works in real life. That's why the comic strip is funny. So we're going to talk about what needs to be done in this phase, maybe create or reuse a design, threat model that design to find vulnerabilities and fix the vulnerabilities. So the threat modeling process is going to happen in this phase, and it's going to serve as a review of the design. And if you want to get better, you can introduce reusability, which is kind of what we're going to assume you're going to do as part of this paved road and what we're going to talk about throughout the rest of one of the many things we're going to talk about throughout the rest of this presentation is, can you have a reusable design that bundles with it things that are going to happen, like libraries that are going to get used in the development phase, that do the things we said we wanted to do on the requirements list. You know, if we want to do OAuth, well, that can get pretty complicated. Why not have somebody who knows about it, who's a good developer and a subject matter expert, write one library once to do this, and everybody else reuses that, rather than maybe on the next project you don't have anybody who already knows OAuth, and that was a steep learning curve. Just reuse it and design it to be reused and create the libraries to make it reused. So useful links here. OpenSAM stuff just says, I think, what we already talked about there. So here's an example, and this is not the best example. This is just one of the many things that's available online. So here's your service that's going to talk through an API gateway such as Apogee to any one of a number of microservices over here. So we're building one of these microservices, say the REST service that's providing product info. So you go to a URL, give it a product, and you get back the product info, assuming you're authorized. So this is a high-level system design. Now you can see over here, this would be one of the servers that is going and asking for the data from the API, and they've actually gone deeper into it and said, well, let's use a model view controller setup for this. That's kind of a deeper level of design. Since we're actually talking about this service over here, we would want to do a lower level software design for this service. But at this point, we want to consider what's the best pattern. We want to keep the microservices small, simple, and we want to offload as many security concerns as we can, either to the API gateway or to those reusable libraries that I talked about, or to other tools. There's also a sidecar pattern where this microservice has a chunk of code that's completely reused. So some of that goes into how we design the microservice, but we're also going to put this API gateway in there. If you're familiar with a reverse proxy, that's kind of a technical term for what it does, but it's a single entry point so that the client has to go through that to get to any of the microservices back here, and that's a logical place to put authentication, authorization, OAuth and OIDC handshaking and token handling and all that stuff, as well as you need to register these services, which we'll talk about more later, do some logging and message traffic. That's a lot of work that each of these microservices doesn't have to do, and that keeps them small and simple. I thought maybe that would be a question. But yes, do jump in with questions. That's the only way we get this easier to understand. There's a lot of info here. If you're asking a question, you're on mute. Please unmute yourself.
Yeah, guys, feel free to write your questions in chat also.
Yeah, and Ankita and Ankush and anybody else, if you see a question in the chat and I don't get to it, it's just because I can only see one screen at a time here on this system. But please refer me to it if you'd be so good. So now we want to build your code, and I'm going to break this into two pieces, writing the code and building it. I'll actually talk about building it on the next slide with the testing and chop off a piece of the process here in this phase and talk about it with the testing there. But right now, let's talk about somebody actually writing the code. And that's kind of, well, there's a CEO of Microsoft that had a speech he gave to everybody where the first 5 minutes of the speech were him just passionately repeating the word developers over and over and over because he thought that was the most important thing. Because if you don't have developers, you don't have anything. You know, you've got some requirements listed here, you've got design here, you've got some tests here, but no code to test unless you have a developer. So this is kind of one of the key portions where you have to write the code security, or better yet, you use secure by design. And in the design phase, you design some libraries which you build once, and then for every microservice, you reuse the libraries. But there's still a lot of code writing here because if you build an OAuth library, or let's just say a logging library that's nice and simple, the developer still has to call that library. They still have to pass the right information to that library. So there's a lot of integration that always needs to happen no matter how you try to make things reusable, and that integration can be challenging. But this is where you write the code, and you know, the OAuths things say, make sure you do this, make sure you write a good input validation routine or a good logging routine. Here's what it should look like, but you have to design and write that yourself. An improved way of doing it is, again, libraries, reusability. So now we've moved to another phase. All right, testing. Here's where we start building things and getting tools involved. We've got code written here. In order to test it, you have to use the CI/CD pipeline or some other reusable building methodology, and that's where you would put some testing in there. And you'd want to include API-specific testing, since this is an API providing microservice that we're building here. So probably want to get some DAST testing in there that exercises the various different URLs that can be called in this API, because SAST testing doesn't know how to track one thing to another. Let's see what happens. Sidecar pattern enhances the security posture of microservices and what specific security. Okay. Good question about using a sidecar in microservices architecture. So up here, let's break this down. We've got a detailed breakdown of what the service looks like. What we need is a detailed breakdown of what this looks like. I don't have a diagram for this, but I did this in another talk I gave years ago. Basically, you break this down into the code that's specific to each of these. So let's say the product info service, recommendation service, each of these has their own code to do their own business logic. And then imagine where it says REST over here. This is another piece, this little square on the side. This is your sidecar. And so you can use the same sidecar in maybe all your REST services. And it knows how to do logging. And it knows how to respond to the API's health checks. All the cross-cutting concerns that every microservice needs to do, again, put them in here and just write them once. Now, these can be libraries. These can be, some people try to implement this as a separate service. That gets a little too complicated for my thinking. But all the things that need to happen that every microservice needs to do, you put in the sidecar, which again, could be implemented a number of ways. But there's code over here that's reusable, and it does all the cross-cutting security concerns that you can possibly put in there, but it doesn't know anything about product info. It doesn't know how to talk to the database that's probably sitting over here that has all the product over info into it. It might know how to respond to a message and do the low-level authorization that needs to happen here. The API gateway says, are you authorized to talk to the service? But then the service says, hey, are you authorized to get this data? Maybe this is actually a data that maybe this is a microservice that provides customer info, and you know, somebody wants to get customer info on somebody else. No, you have to be the customer or be part of the company that does all this to get customer info. You can't just get Ankita's customer info when you're neither Ankita nor the company that's doing the work here. You can't just have some other customer try and do that. So that level of authorization needs to happen here, and if possible, that'd be a great thing to put in the sidecar. Other thoughts on that question or answer? Other questions? So I know Octo does some good testing here, a couple of different ways, and can be integrated into the CI/CD pipeline. That's one thing you might want to do. Another thing is DAST testing. Lots of different options to do this, but you want reusable testing, and in this case, you'd want it to exercise APIs and check for things that APIs need to do. Again, the OAuth, the OIDC, make sure all the authorization is done right, the logging doesn't have sensitive data in it. Okay, now we'll talk about acceptance and deployment. There's a bunch of API specific things that need to happen here. A lot of what we talked about in requirements, it's the same for every kind of code you want. If you want to build a mainframe application, you still need to say what it has to do in the requirements phase. You need to design it here. You need to write some code here. The tools will be a little bit different. The designs will be a little bit different. But now when we get to how to deploy things and how to secure APIs, that gets a little bit different. Oh, I see there's some questions here in the chat. Okay, nothing new there. Please jump in with more questions. So things that are specific to the API is maybe an inventory. So this API gateway here is not going to route traffic to a microservice it doesn't know about. And in fact, you have a problem with developers deploying their own microservices for their own purposes, and they may not be known about by the company, may not be supported. These are called shadow microservices or shadow APIs because they abbreviate API providing microservice as just API. So you've got this shadow service running out here. Well, the way to stop that is to say everybody has to use the API. No traffic can get to the microservices without going through the API gateway. And that means you need an inventory. And you need to say, hey.
I think there's a question in Q&A. The question is, how do you convince developers about slowing down CI/CD pipeline for security testing?
Thank you for pointing that out. So you usually don't want to slow down the CI/CD pipeline for security testing. You actually want to make your tests run in such a way that it's fast. It may take time to get there, but a lot of people will do a phased approach where they start their CI/CD pipeline and they start the process of inserting security into the CI/CD pipeline by just starting with a few simple tests that do not generate a lot of false positives. Clearly you're doing this wrong. There's no question about it. And so you put those in and you start with tests that run fast. They've got no errant behavior. And when that test fails, it's serious. And that's when you want to stop the CI/CD pipeline and break the build. You start with that, you build developer confidence in that, and then you gradually add more things as you get better at writing tests for a CI/CD pipeline. But you make your tests fast, and a lot of how you do this is dependent on what kind of company you are, what kind of software you're writing. I talked to some people recently who don't do a lot of security because they're just writing servers that serve up marketing material, and it's all publicly accessible. On the other hand, I work for a bank, and we can all agree, I think, that it's central to the functionality of a bank that there is some security. If Ankita deposits money and Ankush can pull it out, and it's not a joint bank account, it's supposed to be just Ankita's money, and somebody else can get to it, that's a problem. Nobody's going to use that bank. If you don't have security, you don't have a bank. So I go in with a perspective like that and try to say, hey, for this, let's say a banking application, we have to make sure that only the right customer can get their money out. So we have to have testing. It's not something that's optional. But again, that's going to vary depending on what kind of software you're building. So you emphasize the need for security separately, and you build the CI/CD pipeline such that it minimally interferes with development, and only when there's something serious going on. That's one thing to do. And then the DAST testing, for instance, would be separate from the CI/CD pipeline, and you could put a different type of testing in there. It looks like Ankush is typing his version of an answer there too, which is fine. We can get some different perspective on things.
Yeah, I
if
think
you
it's
have,
written your perspective here.
okay. If you have variations on the question or need more info, please jump in. As you can see, there's a delay between when somebody puts something in the chat and when I notice it up there. So the CI/CD pipeline is going to operate here, but in addition, you need to ensure that you have an inventory and that you can check it so that you've got a tool that checks, which APIs are allowed to run, who is talking to them, what kind of data are they sending there. You need some DAST-like testing that operates on the running microservice after it's been through the CI/CD pipeline and it's deployed maybe to dev or test or prod. You need that kind of testing and maybe other verifications as well. You need tools to discover microservices. And again, I think these things with the asterisks are things that I hear that Okta does well. And I was very impressed by their demos, which is why we're here. But I'll let Ankita and Ankush and others from Okta tell you about that, because they are more familiar with it than I. You need to scan the operating microservices and periodically inspect the traffic, create behavior models, trigger alerts if anything's wrong. Also, there's other types of testing here that would apply to everything, but these bold things of inventory, discovery, and scanning are kind of specific to APIs. Anything else you build should also be red team tested, should also figure users are going to abuse it. There's a lot more information in some of the references here than we can dig into in such a short conversation. Let's see, any more stuff up here? Looks like there's something. Plays to ensure the actions of the red team do not inadvertently affect the real data or operations of the bank during security testing. Excellent question. But the way it's phrased is going to vary from one company to another and one process to another. One of the things you want to do is coordinate what the red team's allowed to do and how you're going to convert that information as feedback to the development team, because they need to fix it. A lot of places I've worked, the red team operates very silently. Another way you could do it is have the red team test everything in UAT. I've seen places where there's a whole separate production environment, and unknown to the developers, when they try to deploy code to production, it actually goes to two places: the production that users can see. Okay, sorry about that. So lots of different ways to do red team. One is to have the red team test in UAT. One is to set up a whole separate prod environment. There's one for the users and one for the red team. I've seen that done before, and often developers don't know there's that extra prod environment where the red team is messing around. I like the idea of purple teaming, where the red team and the developers, who are supposed to be the blue team, work very closely together. And the red team gives feedback to them. So you have to build your own setup, and it's going to vary from one company or environment to another.
There's another question for you, Joe, on the chat.
Okay, can you guys see my screen? Do I have to reshare it? I'm
You have to
guessing I have to reshare it. Okay, let me start that and then I'll answer the question, since I'm here with my mouse pointing to things that you can't see. All right, so now it says I'm sharing. Good, we've got a bunch of questions here. Could you explain Sidecar? Did that my connection bad? Well, we answered that question. It was mine. Sorry about that. Normally it doesn't do that. Let's see. Geophysics. All right. I did a lot of physics. Got a master's degree, was working on a PhD. I like that approach. What kind of vulnerabilities have you discovered in production which were not caught during the P4D or testing stage? What's P4D?
Yeah, what's P4D?
Is that a typo? Is it meant to be prod
Yeah.
or
Yeah, it's meant
UAT?
to be prod. Yeah.
Okay. So I'm not here representing my company, and I'm certainly not going to talk about what was found at any particular company. Um, so what I would encourage you to do is answer that question for yourself wherever you work now. Go talk to the testing people. You will be surprised. Um, Things like hard-coded passwords, which I thought, we were over that in 2008. Now it's 2024, 16 years later. Lots of people still find that, still find secrets embedded in their code. That's why as we move to cloud, people adopt secret scanning, and that's a good thing to do, and all kinds of tests to avoid that. One of the things, as I was talking recently with some OWASP friends who run a chapter for OWASP, and they run their own pen testing company. And one of the things they said is in their experience, now mind you, I'm a former developer. I've got nothing against developers, but in their experience, developers write terrible code most of the time. And that's something you can't fix. You can encourage, you can educate. That's why we're giving a design with things built in and guidance like the OWASP Top 10 be used in the development and building phase. But you've got to educate your developers for security. You've got to make sure that, common thing, this page is supposed to be checked, and you should only be able to access this page of the website if you're an admin user in the admin group. And somehow there's no check on it, and everybody can get to it. That's a problem. So a lot of things like that typically come up across the board at everybody's company, and we have to do better, and that's what this talk is all about. That's what the OWASP organization that I'm part of is all about. Let's see if there's other questions here. Production for deployment. Okay, so that's every company has their own environment. I'm used to like dev, test, UAT, and prod as 4 environments. I've also seen SIT imposed in there for a certain kind of testing. There's other things. Production for deployment sounds like it's a junior production environment. So you may or may not have that. Your mileage may vary. So good conversations. Let's go in there. What measures are in place? Okay, so I'm seeing older. There we go. So are there any questions that you guys didn't already answer for people?
Yeah, I think Joe, all of these are for you. Can you see the question from Anshit, Mohit, Kalyan? I think he's written 2 questions. So first question is, the slide references shadow microservices. How do you typically discover these, and what are the potential risks they pose to API security?
So I think I talked a little bit about that. Hopefully it was not while I was disconnected, but shadow microservices are something a developer deploys perhaps that nobody else knows about, or that is not officially doing what it's supposed to be. In this environment, we've designed everything to use the API gateway. And if somebody wants to test something real quick and they somehow get it in prod over here and they just have somebody talking to it, that's a shadow microservice. It's not part of the inventory. It's not authorized to exist, and yet it's out in production or some other environment. Typically, production is what people care most about. So that's a shadow microservice, and there are various tools. I hear Okta does a good job of that, detecting those, seeing what kind of traffic is out there. There's other companies that make similar tools. Was there another question, or maybe another part of that question?
Yeah, there are a couple of other questions in Q&A itself. Can you see that?
Apparently, because I joined just now, I don't get to see them.
I'll tell you the question. I deal with false positives every day from across tools. How do you deal with alert fatigue in the sea of false positives?
How do we deal with what in the sea of false positives?
Alert fatigue. How do you deal
Alert
with alert
fatigue.
fatigue?
Okay, so yeah, that varies from tool to tool and environment to environment, but typically there's some kind of configuration that you do to reduce false positives, or you change your tests to reduce false positives. But it's a long process typically for the AppSec team to dial in on everything. You know, maybe you don't want to do API tests unless you're actually testing an API. If you're testing a mainframe application or something that doesn't provide an API, maybe you shouldn't run those tests because they're going to give you false positives. Maybe you should run, and so much of this is dependent on your environment. You know, maybe you should run tests that are specific to what you're testing. Maybe you should clean up and improve your tests. Maybe you should improve the tolerances and the configuration of your tool. That varies from tool to tool. Recently, somebody moved on from my company to another job. It was very sad. We all had a going away party, and everybody was talking about the tools she had worked on and how hard it was to get it properly tuned to avoid false positives. I won't mention the name of the tool, but that's again going to vary. How much tooling is too much in CI/CD? Well, that's a whole separate talk, and I've heard many talks on that subject. So, not seeing any more questions. Were there any more?
No, these are all. Yeah.
Okay. So the basic idea here, this is kind of the conclusion, is let's move work from later phases into the design phase. So by designing something carefully, you avoid developers introducing bugs that you have to find in the testing phase. By building libraries once, you skip for this microservice some of the work that would have been built. It was actually happening in the design phase. So this is what shift left means to me. People use it for lots of different things, but to me, shift left means you move work from later phases of the SDLC into the design and maybe the requirements phase. And that's where you get a win because the earlier in the SDLC you fix things, the cheaper they are to fix, up to 100 times cheaper to fix versus after you deploy it. So this is kind of the idea of the paved road. Put stuff that developers can do to improve things in every phase of the SDLC, and that way you shift left, that way you reduce things and make it easier for everybody, reduce risk. So I think we might be close to out of time here. If there are other questions, I'm happy to answer them. If not, Ankita, you can move on to what you had in mind doing next.
Yeah, we have 6 minutes. So guys, feel free to ask whatever you want to ask. What I'll meanwhile do is I'll share my screen and share with you your 2024 roadmap for API security. Just give me a moment. Yeah, I hope everyone can see my screen. So this is really quick 2 to 3 minutes, 2024 roadmap. And it's, as I think about it, we are already in Q1. It started, today is Jan 18. So these are very quick 4 things we can implement every quarter. Q1, Q2, Q3, Q4 to really have the ball rolling in for API security in DevSecOps. And I'll touch upon it a little bit. So we start with Q1. I think for all the people over here who are really looking to implement API security in DevSecOps, you have to start from discovering all your API assets. You can't secure APIs if you don't know what your APIs are. So you absolutely have to know your all of your API assets, internal APIs, external APIs, your critical APIs, your APIs which are leaking sensitive data. You should have a complete inventory and it should be always updated. That's the goal. I think if you're taking anything away from this presentation, you should totally have that in Q1. Q2, you should be thinking about, now you have an API inventory. How? The very simple step is how to scan APIs in CI/CD. Now, you start from API scanning and then put it in CI/CD. Don't put it on block mode because I think somebody asked this question also. How do you not slow the pipeline? How do you make sure that the release still happens and there's no, the release cycle is not slowed down because of API scanning. So that's what you want to do. Q3 is, now that you know all the flaws from Q2, that you tested the APIs, there are broken authentication vulnerabilities, there are rate limiting vulnerabilities, and I think Joe has touched upon these things. You really want to do API. You really want to secure APIs at the design phase. You want to have the right authentication authorization protocols. You want to put input validation checks in the code itself. You want to have rate limiting at the gateway level. And that's really Q3. And this is not easy. This is literally a process that you have to implement in your organization. And for Q4 2024, I don't think this can be done without a proper feedback loop. And somebody asked this question again, you have tons of tools. How do you manage the alert fatigue? So you don't have to prioritize every single vulnerability. You really have to know, what are your top 10% critical vulnerabilities, and give that feedback to the developer. You can't throw all the problems to the developer. You have to really prioritize the critical ones. So now I think we have only 2 minutes left. I leave you there. This is exactly what Acto does. We automate inventory, we do API scanning in CI/CD. We'll give you that feedback loop. For the third thing, that's really a process thing: secure authentication, authorization, and rate limiting. And we have tons of recommendation on the tools that you should be implementing for this. Lastly, this is Acto. If you want to get a personalized demo, you have a link over here. Go ahead, sign up for the demo. We are building very, very exciting stuff. So you can, and we're posting about it every day on social media. So you can go on LinkedIn and Twitter and follow us. I'll just stop sharing my screen, and I want to thank Joe for being here and, like giving this wonderful presentation. I have not seen this presentation before. So this is amazing. I think we'll have this recording and we'll share it with everyone. So thanks guys for joining. Are there any more questions here?
Thanks for having me. Looks like there was one question that started with your name.
Yeah, at Ankita, the chart on the CI/CD slide displays the number of vulnerabilities over time. How do you prioritize which vulnerabilities to address first when such a scan identifies multiple issues? Okay, which chart was that? I'll just share my screen so that the chart is visible. I guess this one. Yeah, this one.
Yeah, I think okay, sorry about that. I hope you can hear me. Yeah, the best way to start with, I think, is to simply start with the red ones. The red ones are high or critical level vulnerabilities. Even further, I think sometimes you might have to, as Ankita mentioned, brutally prioritize. So even there, I think broken authentication and broken authorization vulnerabilities should be addressed first. That's the ones you would want to prioritize first. They are probably the most disastrous ones. Yeah, that's it.
Great. Any other question? I see. No, and we are out of time also. Great. This was a great webinar. Thank you guys for joining us on a working day. Thanks, Joe, for being here. Lovely presentation. Thank you so much. Appreciate it. Thank you. Thanks, guys. Bye-bye. Have a good day. Take care.